Hello, my dear friends. Today I am coming before you with 5 board examination questions. As we are all going through certain stressful conditions. I apologize for my earlier videos to be somewhat in a fast-forward manner because I thought about making you convinced in the fastest way possible, but one of my friends told that your people need care for understanding it better and clearly. So after all these videos which I have put earlier, from now on I'll give you much more care to make you understand all that basics of all these subjects of physics, chemistry, maths in the Guru Pro channel. So what all which I am teaching you is a common set of all board examinations, competitive examinations, to understand the basics, the fundamentals of the topics. So don't skip a video because it will make you sharp in what all concepts which you are dealing with. It will give you a basic idea, and try to view this because this is all intricate writings now. So if you need it, the clarity, it will not be available in the 360 pixel view. So this is a big whiteboard. So what all I am teaching you, if you want to see it more clearly, you should just download my videos. Just let it be downloaded in the 720 pixel range because I have made it shrinked. To this video is shrinked. The clarity video which I have took is shrinked to below or nearly 100 MB or less than 50 MB also some videos. So we can return to our what are all topics which I am dealing with. So today we are dealing with 5 questions. Don't get afraid because I am with you. I will tell you what all is needed to crack all this the examination based board exam questions, competitive examination questions, everything. So first of all, do like, share, and subscribe my channel because without your support, it is very difficult. For the first question is given a diagram which is showing the current flowing through the following circuit. This is the circuit, the fundamental circuit which is given. What is the current flowing through the circuit? But this current, which we want to find out, what all is given? A voltage is given, and the resistances meshes are given. The 2 ohm, which is in series with the 8 ohm, which is these two are in parallel, and again this comes another 2 ohm. So the current goes like this: 2 ohm is encountered, a parallel connection of 8 ohm and 8 ohm is encountered, and 2 ohm is, and then it is connected to here, positive to the negative terminal. Voltage is given. So first of all, for finding out by the equation V is equal to IR equation, this equation, we want to clear out what all is the resistances, the effective resistances, So these two are parallel, 8 ohm are parallel. So this 8 ohm, when it is written in parallel connection, the equation is 1 by R effective is equal to 1 by R1 plus 1 by R2. This is 8 ohm, this is R1, 8 ohm, this is R2. 1 by 8 plus 1 by 8, 2 by 8. It is cut off, then 1 by 4 or something. No, the thing is 2 by 8, 1 by R effective is equal to 2 by 8, then R effective is equal to reciprocal of this 8 by 2. When it is cut off, 4 ohm. Okay, R effective. But this 8 ohm parallel connection is then I will replace by this diagram. Okay, so Again, this diagram has changed now. 2 ohm is there, but this is placed by this 4 ohm. 4 ohm which is got by. So this 4 ohm, when it is when we encounter the current, no, this current is going through 2 and then 4 ohm resistance and then comes 2 ohm. So these three are in series now. Oh, so that we can just add it. So the effective resistance of these three resistances is 2 ohm plus 4 ohm plus 2 ohm. Okay, 8 ohm. This is the answer. So R effective total is equal to 8 ohm. This is the diagram which is written over here. So I have eliminated all that complexities of resistances and given a single resistance 8 ohm, which is written. Now we can find out the current very easily. No, and what is that? The equation is V is equal to IR, and 4 voltage is the voltage which is given 4 volt. Current I, let it be indicated as I, which is given in the figure I. So what is R? We got the total resistance effective 8 ohm. So 4 volt is equal to I into 8 ohm. 4 volt is equal to I into 8 ohm. Is equal to I, let it be here. Let the I get isolated on one side. Then 4 volt divided by 8 ohm. This is the thing. Remove all this V and ohm. Just I want to make you understand this is this thing. So I is equal to 4 by 8. That means the half of 8 is in the numerator. Cut off. Then 1 by 2. 1 by 2 is 0.5 amp. So this is the answer. 0.5 ampere is the current flowing through a circuit having 8 ohm resistance as effective resistance and a source having 4 volt battery. Okay, it is finished. Then find the effective resistance of the circuit. This is a complex circuit. Now next question. So this is a complex circuit, but just when we look at this now, there is this thing that when we look at the periphery, okay, 2 ohm is connected to, okay, A, and then again 21 ohm and then B. Okay, this is the thing. I can reduce this figure into a simple form, that is A and 21 ohm and then to B. Okay, then again A to 3 ohm. Okay, then a block is there and then it is encountering 6 ohm and then B. A 3 ohm, there is a joint and then encountering 6 ohm, then B. Then third is A 6 ohm, then there is a joint and it is going through 12 ohm and it is going to B. Okay, this is A, it is going to 6 ohm, then there is a joint 12 ohm and then joins B. Then the other A, it is going to 7 ohm, the periphery, the bottommost periphery, 7 ohm, and getting through here to B. This is the simplified version of this diagram. This. Okay. Then just look at this again. The 3 and 6 are in parallel now. 6 and 12 are in parallel now. So we want to simplify again this. So when these two are in parallel, 1 by R effective 1, these two, is equal to 1 by 3 plus 1 by 6, making the denominator same. That means bottom and numerator and denominator by 2, making the denominator same. 2 by 6 plus 1 by 6. 1 by 3 plus 1 by 6 is equal to this 3. We want to make it 6 now. So 3 into 2, again numerator into 2. That is 2 by 6 plus 1 by 6 is equal to 3 by 6. That's it. R effective, this thing now, when it is reciprocated, that's the R effective 1. That is 1 by R effective is equal to 3 by 6. Then R effective is equal to 6 by 3. That is 6 by 3 is 2 ohm. R effective 1 is equal to 2 ohm. When we can replace this by 2. Again, this R effective 2. 1 by R effective 2 is equal to 1 by 6 plus 1 by 12. Okay, making the denominator same, 3 by 12. Then R effective 2 is equal to 12 by 3. That is 4 ohm. Replacing the whole by 4 ohm. Then R effective 3. That means these two things we have got now. These two parallel connections are replaced by this 2. These two parallel connections are replaced by 4. Then this thing now, we can again make it one thing. It is 2 plus 4. They are in series now. So 2 plus 4 is equal to 6 ohm. Then again, the same diagram, we can make it simple now. 21, 6 and 7. So the whole effective resistance as a whole is given by R effective 4. So 1 by 21. It is, these three are in parallel connection. So 1 by R effective. 1 by R effective. Okay, excuse me, because I have written like this. That means 1 by R effective. You want to write it 1 by R effective force equal to. That means in a haste I have written this. R effective force equal to reciprocal sum 1 by 21 plus 1 by 6 plus 1 by 7. That's it. So making the whole thing denominator same. That means 42. Take the denominator to be 42 along all these. So 2 into 21 42. 6 into 7 42. 7 into 6 42. So this we will get 1 by R effective is equal to 15 by 42. Then R effective is equal to 42 by 15 is equal to 2.8 ohm. Okay, have we got? We can be so the effective resistance of the whole circuit is 42 by 15. That is 2.8 ohm. Is the answer. So practice well these all things. Then these are all which I am telling you are doubt dispeller sections. That means if you have any doubts, it will get vanished by looking at what all I am telling you in these videos, practicing it well, looking it clearly. If I have that technological plus point, I would like to make it very clear to you, but I have only this facet of a two big whiteboard. So if you download and see, just see it in the the best quality which you have. That means 720 pixel clarity. You can see all these classes. So just see what I have written in the clear manner, what I have told you, elucidating all that, making it in the lucid manner, most easy manner. So see my videos in the most better quality which is available to you all. The doubt dispeller section, it is asked, first of all, acquaintance with the earlier sentence which I have said. The Wheatstone's bridge is a sensitive device to measure resistances. Okay, Wheatstone bridge, there is a balancing condition, there is an unknown resistance. Okay, by that, it is a sensitive device to measure the unknown resistances. The basic condition, if you don't know anything also, you can write P by Q is equal to R by S. That's the essence. So it will be in the case of looking like this. But the question 3 goes like this. When does Wheatstone's bridge become more sensitive? What is the condition the Wheatstone's bridge becomes more sensitive? That is right like this. The Wheatstone's bridge becomes more sensitive when all the 4 resistors are of the same value. If the 4 resistors now P, Q, R and S are of nearly the same value, which is equal to somewhat near values, then that resistances mesh now will be becoming more and more sensitive. That means it's very difficult to find out the differences. So it is more sensitive. If you have very big different values, 2, 1, 2, 4, 8 different values, that Wheatstone's bridge is not that sensible. But if you have a resistance values 1.12, 1.13, 1.14, 1.15, then that resistance, it is having same values, nearly similar values, then that Wheatstone's bridge is more sensitive. When does Wheatstone's bridge become more sensitive? When all the 4 resistors are of same value. Okay, in this diagram, when a balanced bridge across A and B, it is given now. Find out the effective resistance. Okay, then we know the Wheatstone's principle. When this diagram is given, the IG current when it is 0, when the potential difference between these two ends are 0, then this bridge is balanced, and then 4 by 2 is equal to 8 by 4. That's the essence. But when that balance condition is there, no current pass through 2 ohm, no? So this circuit becomes like this. So they are telling what is the effective resistance of this circuit. Then just you want to know that basics of a series and parallel formulas, no? So it will be like 4 2 and 8 4, and just 4 plus 2 is in series. 4 and 2 are in series. 4 plus 2 6. 8 and 4 are in series. 12. Then these two are in parallel. The 1 by R effective is equal to 1 by 6 plus 1 by 12. That is written over here. That means making the denominator same. 2 by 12 plus 1 by 12. Okay. 6 into 2, 1 into 2. This thing. So 2 by 12 plus 1 by 12 is equal to 3 by 12. 3 by 12, we can cut off 3, 1 by 4. So 1 by R effective is equal to 1 by 4. R effective is equal to 4 by 1 is equal to 4 ohm. That is the effective resistance found out. These are all asked in the board examination questions. Then the next question goes like this. Why is the Wheatstone's bridge method preferred for measuring resistances than any other method? Why this Wheatstone's bridge is preferred than any other method for measuring the resistances? Because this is a null point deflection method. Now, null point deflection method, that means there is no loss of energy. That means IG current is zero, potential difference is zero, there is no heat loss, because when all current passes through this thing, there is a loss of energy. We can all write in a very ordered manner like this. It's a null position deflected method. That means in which there is no current through the galvanometer G position. Hence, there is no loss of energy due to heating effect. That's why the loss of energy due to heating effect is less. That's why it is much more preferred than any other method. That's the essence. When we come to the question number 5, this question is telling this diagram. Find X magnitude. What is the value of X over here when no current flows through 5 ohm? When no currents flow through 5 ohm, this resistance, justify or reply. Oh, in the question itself, it is given find out X, and there is when no current is passing through 5 ohm, this resistance is similarizing to a Wheatstone's bridge. This thing, this X, this 18, this 18. Make it somewhat like this. When I have stretched this thing and this thing towards the top, it will look like this now. So when this look like a Wheatstone's bridge, when no current is passing through this 5 ohm, it is called a balance condition. So no current is passing through this 5 ohm. So this P by Q is equal to R by S. That means X by 18 is equal to 2 by 6, which is written over here. So when getting full marks, you must write in the Wheatstone's bridge, if it is balanced, the IG current is 0. The potential difference between these 2 points are 0. Okay. The junction, the point between X and 18 and the point between 2 and 6, the potential difference between these 2 points are 0. The current is also 0. So this balancing condition will become Wheatstone's bridge condition. So P by Q is equal to R by S, X by 18 is equal to 2 by 6. Then we can simplify this equation in the form 6 into X one side, 18 into 2 the other side. So 6X is equal to 18 into 2. This 6 and 18 get cancelled out. X is equal to 3 into 2, that is X is equal to 6 ohm. That's it. We have got the magnitude of X. Again, at IG is equal to 0. What is this? Okay, this is the balancing condition. You want to get the maximum marks possible. So, for the examiner to be fully satisfied by your answering style, the thing is that at IG is equal to 0, no current through 5 ohm is there. There is no current passing through 5 ohm. Again, in the null deflection point method, the balancing condition when it is arriving, difference between both, the potential difference between both ends of the galvanometer is 0. That means I have said earlier, when talking in a Wheatstone's bridge, in the balancing condition, the galvanometer current is 0 because due to the potential difference in that between C and D is 0, or over here and here the potential difference is 0, the current is also 0. That's you want to write fully. So IG is equal to 0 across 5 IG across 5 ohm is 0. The current through 5 ohm is 0 and potential difference across 5 ohm is equal to 0. So write in a very nice sentence. That's it. That's the essence. Again, at null deflection point method of balancing conditions, the potential difference between both ends of the galvanometer is 0. That's the essence. So, see you in the next video. If you have any doubt, call me in my number, comment in my comment box. I'll be with you, giving you practice on every chapter. I do have wish to get into the physics and chemistry and mathematics part also, but I'll be there for you with much more videos in chemistry and maths also. So please subscribe, like my physics, chemistry, maths guru bro channel. Be happy, be cool. study what are all the board examination, competitive examinations, entrance-based questions which I have brought before you. Support me. Without your support, okay, without your support, my channel need your support. So I beg before you all to support. Please support my channel. Bye. Be happy. Be cool. Bye. I'll see you in the next video.